exercise 3a, we are asked to explain the difference between random forests and bagging. There isn't that much difference. The difference in bagged trees and random forests lies in the decorrelation of trees. So, as the professor showed in the lectures, the problem with bagging is that as the bagged model uses the whole set of trees, the whole set of features, the trees will be heavily correlated because they will roughly use the same feature for splitting at the first time and then for the second and third. So the trees will look very much alike. So bagged models consist of many trees that are all trained on the same set of features, although we have to say that we use different bootstrap samples, but those are just regarding the observations and not the features. So in the bootstrap we select different observations, but we won't select just a reduced number of features. We will still select all the features. Due to this, the splits in each tree will likely occur for equal variables at the same steps, which will lead to heavily correlated trees. Now, when we choose only a subset of the available features, the splits might occur for different variables at different time steps. So, if we won't have the most important variables anymore available, then we might use different ones, and this will lead to different splits. And this might lead to improvements that we wouldn't have considered even before, because they wouldn't be viable due to this the splitting that we had before. I mean, if you think about what we had with the when we talked about the greedy approach, the top-down greedy approach, we said that we won't consider a split at later steps if the split right now isn't feasible or isn't viable in regard to the improvement. But this time now, when we have different sets of features available, we might end up with kind of splits that we wouldn't have considered before, and now we consider it because some variables are just not in the set anymore. So this is the kind of potential that we want to unleash here, and now each of the trained trees will be much worse in prediction compared to a tree that uses all the available features, just because they don't have enough information to make good predictions individually. But when we ensemble them together to a combined model, to a combined random forest, then like magically they will perform much better than the normal individual models and the normal decision trees with all the available features, and also better than the bagged trees that consist of many trees with all the available features available at training, just because we get rid of the correlation between the trees.